Hello and welcome to Ngwasheng Online Maths Academy. My name is Ngwasheng. I'm gonna do general solution trigonometry. Then after this video, I'm gonna also do a lesson based on trigonometric identities. But everything that I'm touching or doing, it will be exam based. Then after that video, I'm doing another video that is based on nature of the roots. And after that, I'm also gonna do functions, that is parabola functions, straight line, hyperbola. But this time we're going to do the interpretation of the graph. So now let's get on to this, because I don't want this video to be too long. Let's understand what is general solution. Basically, we are dealing with trigonometric equations. We know equations from paper 1 algebra. We are doing equations again under trigonometry, which we are focusing on general solution. So this time, we are all that I'm doing, there's no restriction. Understand why I say no restriction. They'll give you equation like that. If there's a restriction, they're gonna tell you that find a solution between 0 to 360, or between negative 180 and 270, whatever. But in this case, there's no restriction. Now, when there's no restriction, does it change how we do things even if there was a restriction? No. Now, pay attention. The key words here: reference angle. Let's check on that, because we're going to talk more about a reference angle. Once you understand what is a reference angle, everything is going to make sense. How do you find a reference angle? Anything you get after you shifted a ratio. A ratio I'm referring to trig ratio. It can be sine, it can be cos, it can be tan. Once you shift any of this, the answer that you're going to get is a reference angle. Now, let's start here, because I'm looking for this. Basically, all this is like we are solving for theta. It's an angle. We are not solving for a reference angle. We are solving for an angle, theta, which is somehow is different when we are talking about general solution. Now, most learners, they've got tendency of doing this. Eventually, you are getting your 30. After I shifted sign, I got a 30. It makes a 30 to become my reference angle. What is my reference angle? It's 30. Now, since my reference angle is 30, let us show you how to proceed. Because most learners, they just end up here. Even when they come to this point, as long as they get their theta, they think they are done, even coming on the other side. But now listen, this video is dedicated on general solution with no restriction. I'll do more since I know learners will be writing their exams. Now, there are two things to consider here. We check the ratio, that is sine. We are talking sine. We check the value of a, what is on the right hand side. Remember, this is in a form of sine theta equals to a. A can be any value, and this value, it can be positive or it can be negative. But when it comes to this ratio, it can be sine, it can be cos, it can be tan. So now let's check. The moment you shift this ratio to whatever the value that you have, the answer you're getting, it is a reference. I think I've said that many times. Now I'm checking, because the ratio that I'm talking about is sine. And this is positive. This is the value of a is positive. Now, according to the Cartesian plane, we have to check where sine is positive. Now, sine is positive in the first quadrant and it's also positive in the second quadrant. Now, I can say, let's get general solution where sine is positive, meaning it's in the first quadrant and the second quadrant. Now, without any waste of time, we know that the Cartesian plane has 180 minus. Here we have a theta. Remember, if I say 0 plus theta, we just get a theta. We know that we've got 180 minus. We've got, 90 minus. We have 90 plus. We have 180 minus. We have 360 minus. But let us not focus on the one that are co-function. Let us we rotate amongst these ones. Sine is positive in the first quadrant. And in the first quadrant, we only have 180 minus theta. Understand one thing. In this case, when we say 180 minus theta, basically we are saying, so the first quadrant is this. We are going to say theta plus 360 times k. This is the notation or the format that you must forever use if you are talking general solution. We are taking it further. This side we are having a 180 minus. Since I say this is theta, it represents the reference angle. Not every theta is a reference angle. So basically this 0 plus 360, it comes from when you add 0 plus a theta, you're still getting a theta, right? So now, this side, 180 minus, I will say 180 minus. Let me change, instead of theta, let me write a reference. Then plus 360 times k. Even here, let's change the theta and make it a reference. Why? Because I said this answer is a reference. And how do you get the reference? Always when you shift one of the trigonometric ratios, if I shift sine, like this is shifted, the answer that I'm getting is reference. So it's not always the case, because you will see when you come to this. Once you shift, you divide by 5, then you shift the sign, the answer you're going to get is your reference. Not to say calculate the value of x, and then that makes it automatically become your reference. Now, let me proceed. From here, what is my reference angle according to this? Is 30. It doesn't matter. Some they say k times 360. It doesn't matter. So just because of my reference is 30, it doesn't mean that every time when you see a theta there, we manipulate whatever we have as if we are solving for theta, and then we are getting the answer which will replace the reference angle. No. A reference angle, we get it when you shift any ratio, any given ratio, can be cos, can be tan, any ratio that is shifted, then the answer you are getting is a reference. Hence, I want to change this into a reference, because if I say theta, then as they'll always think that whenever they see theta, that answer is a reference. No. Now, let's check here. What is my reference? My reference is 30. Now, what is 180 minus 30? We are getting a 150. Remember, these are all angles, degrees. My good people, it ends there. As simple as it is, it ends here. Now, I'm giving you this, which is slightly different from that, so that you can be able to relate. And as you proceed, I started with the simplest one, going to the complex. There are some things which are very much complex than that. But obviously, now for one, to save someone from failing the examination, which are coming soon, so I just want to make sure everything makes sense here, step by step. All right, now let's come to number 2. If you look at number 2, general solution. From your textbook, any textbook, you can check. There are different types of general solution. We've got general solution that are in form of linear. This is part of the linear. We've got the one which are quadratic. We've got ones where we're taking the common factor. We've got the ones where we call it cos rule. We've got the one that is tan cot, cofunction and stuff. There are plenty. But looking at this, we have to manipulate. It will now end up as something of this nature, which is linear. Now, look at this. The moment you see sine cos, think of a ratio like tan theta, which is sine theta over cos. So we are forced to manipulate this to have a tan. And for us to have a tan, sine must be on top, then cos as the bottom. So in this case, I can divide by cos so that it also comes this side. Now you can see that sine over cos can give us a tan. These cancel each other. You remain with a 3. But what is sine over cos? That is a tan of theta. You still have that 2. Now what do you do there? You divide by both sides by 2. Now back to this one. Just after manipulation of whatever we did, back to where we started. Now it becomes easy because we are doing the same thing. How to find the reference angle? Shift tan. So from where you are, if you shift tan, something of this nature, the answer we are going to get, it is our reference. Where is my calculator? It is our reference. Okay, let me get a calculator and work on it. Now, my calculator, when we shift tan, by the way, what is 3 divided by 2? We know is 1,5. So when we shift tan 1,5, I'm getting 56,31. I'm getting 56,31. It happened that just because I shifted my tan, the answer I'm going to get, it is automatically my reference. And then what do we do? Same thing here. Tan, this value of A, remember 3 over 2, the number on the right hand side, we must check whether it's positive or negative. In this case, it is positive. Tan is positive in which quadrant? First quadrant and third. In third, we are getting 180 plus. But in first is always, remember, first we said we are having 0 plus theta, which is just theta. So in the first, and I said theta is reference. So we are having theta plus 360 times k. When it's first, it's always the same thing. Wait, yes. Reference represent theta. So now, let's say, let me indicate first and third. And in third, we're having 180 minus theta. So I'm going to write it as 180 minus reference. Because I say a theta, in this case, we can use this reference. And don't forget that we always add 360 times k or k times 360. I don't know if this is visible because now I can see my space. The more I go down, it's not that much clear. Now, what is my reference? I got 56 plus 31. I mean, comma. So I'm going to say 56, 31 plus 360k. It ends there. Remember, there's no restriction. I will explain before the end of the video what happens if there is a restriction. So make sure you watch till the end. This won't be too long, maybe less than 20 minutes. So now check. It ends here for this. You are done. That is the general solution with no restriction. Now come to other solution. As long as we are saying tan is positive in 2 quadrants. first quadrant and third quadrant. What do you find in the third quadrant? We get 180 minus theta, or 180 minus the reference angle. Now, you'll see as we come to this one, I think you can pause the video now, try to work on that and see, because you already get the ideas of what is happening. Now, the next lesson, like I said before, I have to accommodate the identities and maybe some complex general solution. On your comment section below, please let me know what is it that you want us to do. Now, again, 180 minus my reference angle of 56,31 plus 360 times k. Now, we can just get the solution to say now, what is 56,31 minus, oh, no, it's third, it's not minus, it's plus, right? Yeah, I wanted to punch a calculator. I realized that on a third, remember, this is 180 plus, this is 180 minus. So I quickly realized that I made a mistake. So it's actually plus. So we are adding. So basically, you can add the reference angle of 180 plus 180 plus 56,31. I'm getting solution of 236. I'm getting 236,31 plus 360 times k. Done, my good people. Nothing more, nothing less. Like I said, watch till the end, because this is the last problem that I have to solve. All this is what you find in examination. All this, we are doing the same. We end here. There's no restriction. I know learners, they are very much aware of this, where k is the element of z, integers. I'm going to explain where does that enter, right? So now, let's focus on the last one. Now, pay attention, because this is the last one. Hence, I want to just give you 3 problems. Let me clear space for this one, because it might be a bit complex. So let me just create enough space for that. Yeah, I'll just want to make this lesson to be at least 20 minutes video. All right, so now you'll see what is it that I want to deliver. Sometimes to pass maths, you don't need to do like thousands of activities. However, when you do more years, you become exposed to different kind of problems. Now, what I emphasize in this video is to say, like, reference angle. I'm emphasizing the reference angle. Still wet. I'm trying to emphasize the reference angle. Now, check. How do we find reference angle? Shift a ratio. Then get an answer. That is your reference angle. Exactly. All that we've been doing here is the same. Now let's come to this. You and I, we know that mathematically, you'll start by, because we move from left to right. So we are having a sine of 2x, 5, and 3/5. Now be careful. We are applying the same thing here. Now I have to shift the sign. I have to shift the sign. So let me just write this. I want to see something. I said to get the reference, just shift a ratio, then get an answer. That is your reference angle. So when I shift sign to 3/5, the answer I'm going to get is my reference angle. It's the one that I'm going to use here. Not to say now, let's solve x, take this to the other side. Do no. I want to deliver that. Now let's shift sign 3/2. Or 3/5. 3/5. At 0.6. So shift sine 0.6. I'm getting I'm getting 36 comma, I can say 87. Yes. After I shifted the sign, I'm getting a 36. So now my reference equals to 36.87. That is my reference. Now you know what do we do with the reference. It's easy because now we have been talking sign so far. It was sign. So now we check. Sign is positive in the first and second quadrant. Now you can see that it's a repetition. What we're doing here is like a repetition, but the problem is been given in different form. Now we are having, we say reference angle plus 360 times k as a first quadrant. But here we are having 180 minus reference angle plus 360 times k. My good people, you are done from here. You are done. What is your reference? So you cannot just take this while you are having the problem now start here. That is the problem. I don't have a highlighter, like a different ink. Maybe I will need to use this space because I can see that the more I go down, it don't be visible. Let me bring it here. I say the first reference plus 360. Second, 180 minus 360. No, 180 minus reference plus 360 times k. Now let's engage this one because we haven't used. We cannot just say my reference is 36, and then I assume I got the answer. Remember, this one is different from the previous. Previously, we just had a theta, which is it was automatically our reference, but in this case, it's different. We are having this. What do we do? You take this, you equate to that. You take this, you equate to that. Then you do the same thing. So what do? I'm gonna take that 2x minus 25. I equate with what I have here, which is reference plus 360 times k. Same thing on the right hand side. I take this, my left hand side, 2x minus 25 is equivalent to 180 minus the reference angle plus 360 times k. Let me just avoid that. This is where it ends. If you check where we started, previously we just had a theta equals to 30, which happened to be the reference. But in this case, look, the reference is only this number. This is the reference. What about that? That is when we equate. We take that, we equate to the same thing that we've been doing all along. How did I get this? I checked. Sine is positive in the first and second quadrant. And in the first, we know. Some can say, why we say reference? This is like 0 plus theta. But 0 plus theta is just theta. And theta, it happened to be, we are now, this, we call it the reference of angle, the reference angle. So, this side, we normally say 180 minus. But now we decide to make the reference to be this theta. Not necessary that we calculate the value of x and we make it the reference. Remember, a reference is only when you shift your ratio, then answer we got, it is your reference. So now, I equate what I have with this one. We equate your left with that. So now let's now substitute. What is my reference? Now the reference angle we said is 36.87 plus 360 times k. Same on the other side. Hence, it's easier when you do like in a means of column A and B. So you'll see that you're doing almost the same thing. The difference is the point of reference. Now we are having this equals to 180 minus the reference again is still 36, 36,87 plus 360 times k. All right. Now this is now pure algebra. Remember we are doing trigonometry, but this is pure algebra. So you do what you know best. That means I'll say 36,87. This reference number, since this was a negative, is going to be, I'm adding that 25, but I still have a 360 times k. Now, give us the result of this. This is you grouping the like terms. When you group the like terms, so I'm having 36, that plus a 25. So it gives me 61,87 plus 360 times k. Like indirectly, you are solving for x. But as long as you make sure that you understand how to get the reference, not to say after transpose, I know, and then I will transpose 25 and combine everything, divide by 2, and assume that is the x is the reference. No. We said the reference is only when you remove or transfer what you call shift your sign, your cos or tan, whatever the ratio. Now I have to divide by 2. This is applicable to everything. So that means this 360 times k must be divided by 2, everything. So I'm having x equals so. What is 61,87 divided by 2? We're getting a 30,93 plus. Obviously, 360 divided by 2, we know that is half of that, which is 180 times k. It ends there on this side. Guys, this is normally what they want in exam. For you to get this in exam, you'll be lucky. You'll be lucky. They'll just give you something of this nature. So now, perfect this. Follow, pause, rewind, go back and forth. That is the advantage of watching a video. Now, same thing here. Let's say, now I want to sort out this mess. To say 180 minus 36,87, it gives me 143,13 plus 360 times k. I know it's messy, but if you were with me from the beginning of the lesson, you'll understand. We moved from here, we started here for enough space. So now, let's see. Since I have 143, now I must transpose what? This 25. So this 25 will go with 143. So it's like 143,13 plus 25 plus this 360 times k. Now, when we add that with 25, it goes up, then we are getting a 168. This is 168, 13. We still have a 2x here, and then we still have a 360 times k. Now again, remove 2. It's like basically solving for x. 168 divided by 2, we are getting, you can say 84,1. Plus, obviously, 360 divided by 2, same as that, we're getting 180 times k. Done. On the comment section, you can suggest any problem that you came across as you are preparing in the examination, the test, whatsoever. Please, on the comment section, make sure you engage with us, guys. I'll never know what is it that you want if you don't engage with me on the comment section. Now, this, I wanted to make a 10 minutes video or 20 minutes, but now it's 30 minutes, only with these 3 problems. Now, let me wrap up by saying, why I'm saying there's no restriction for that, we just end here. But if there is a restriction they must give you, at least to say, find the general solution, blah, 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 and then let your answer be between 0 and 360. Remember, this restriction, they can give you any. They can still say between 180 to 720. They can say between 0 to 540. Like they can give you any restriction. But now, because we were not given any restriction here, we end here. What if there was a restriction? For instance, let's consider the restriction where they will say 0 to 360. Now, this is why we say, okay, now, since we say, where, okay, k, sorry, we were given, because of this k is the element of integers. What are the integers? Integers is positive numbers, they are negative, and a 0. That is integers. But the choice is yours. I can choose a value of k to be a 0, another k to be a 1, another k to be a negative 1. I know, learners, you can choose any number as long as you've got a positive and a negative number. But avoid numbers like negative 100, 0, and 100. I mean, with these huge numbers. I know it's possible, but please, exam, we are focusing on the time. We are given time. So now, as long as you are given a restriction of like 0 to 360, you're going to plug where there is k, put 0, get a solution. And check if that solution range between 0 to 360. And you're going to do something like, since it's x, x is the element of, you're going to write all the answers that fall between the range of 0 and 360. Right? Actually, the domain, let me just say the range, because obviously the angles are horizontal. Okay. Now, if I put 1 there, it's 180 times 1. So it's 180 plus 30. The answer that I'm going to get, it will still be between 0 and 360, because it's not above 360, it's not below. If you put a 0 again, 180 times 0 is 0. 0 plus 30, you still get a 30. 30,93 is still one of the correct solution. But when I put 1, like you can add, it will be 210, 30 plus this. If you multiply by 1, it will be 210,93. That is still correct. And then you proceed. After you put a negative 1, remember I have to use them one by one. If I put negative, it's going to be negative 180. So the answer we're going to get here now, it will be a negative number. It's not part of this. So you will never write it there. So now that you're done with all these k values using the first quadrant, you do the same thing. The same k values, you plug them here on the second quadrant. All the answers you're going to write here. Only if the restriction is given. But if not, we don't have to do all this to say, now where there's k, let's plug 0, let's plug 1. So please, make sure you subscribe if you find this useful. More videos will come, and especially now I've been away for like a week or 2. So now I'm forced to give all these lessons that I was supposed to upload sometime last week. All right, now like, share, comment. Tell me what is it that you want me to do. I'll do it. So now the next video is identities. I'm going to deal with identities. Right after this video is identities. Then I'm doing nature of the roots. Thank you for watching.